depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap. This is going to be really fascinating. We have a presentation, we have a demo, lots and lots of really good stuff happening today. So before we get started though, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on demand. After today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience, so if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate, just use your GoToWebinar control panel, your big marker control panel, and submit your questions, and we will try to get to as many as we can near the end of today's webinar. Also, at the end of today's webinar, we are doing a drawing for 3 $50 Amazon gift cards, so please stick around. Hopefully you'll be one of our 3 lucky winners. And we also have a chat function on this interface that allows you to be as interactive and as engaged as you would like. So feel free at any time during the webinar to chat out your thoughts, your commentary, and we will do our best to communicate with you throughout as well. We also have 2 polling questions that we're going to kick off today's webinar with. But before we do that, let's go ahead and kick off today's webinar, which is protecting Red Hat OpenShift container-based applications with cloud-native backup and recovery. Our speakers today are Prashanto Kochavara, who is Director of Product at Trilio, and Annette Cluett, who is Principal Architect over at Red Hat. Annette and Prashanto, thank you so much for joining me today. So glad to see you here.
Thanks.
Thank you, Charlene.
Yeah, and as I said, we are going to kick off today's webinar with 1 polling question. So we'll go ahead and open up the first polling question, let everybody go ahead and make their choice. You can look in the polling tab to see the polling question that is now open. But the question is, do you run stateful applications within Kubernetes? You can choose from yes, in production, yes, evaluating, plan to in the next 6 months, or no, stateless only. So go ahead and make your choice. And I'm going to leave the poll open for a minute or 2. Prashanto, if you'd like to go ahead and start your presentation, I'll take myself off camera, but I'll stay on the back end, and then we can talk about the polling question. You just let me know when you want to discuss the results, and then we'll get on to the second polling question.
Sure thing. Thank you, Charlene. So hi, everyone. Good morning, good afternoon, good evening, wherever you're joining in from. Very warm welcome to you for joining this webinar. As Charlene introduced Annette and myself, we will be talking about the market problem that we are seeing around Kubernetes today as part of the introduction, after which we will be jumping into a quick product overview of the OpenShift container platform as well as OpenShift container storage. After which, we will be going and doing a deep dive into Trilio Vault for Kubernetes, talking about all the different features that are available and how Trilio Vault basically achieves cloud-native data protection. After that, Annette will be doing a demo showing a cross-cluster migration of an application between 2 OpenShift environments. And then finally, we will wrap it all up by talking about the benefits of this collaborative solution that has been built by Red Hat and Trilio together. So with that, I will move into the next polling question. Charlene, I'm assuming we're ready for that?
I am, yes. I just closed the first polling question. The question was, do you run stateful applications within Kubernetes? Of the answers, we had a dead tie at 27% between yes, evaluating, or no, stateless only. That was, as I said, 27% for both of those. And then another 24% said plan to in the next 6 months. 21% said yes, in production. So those are the results of that polling question. So now let's go ahead and push out the second one. The question is, what do you use to manage applications within Kubernetes? You can choose from Helm, operators, labels, or namespaces. Again, that polling question is now open. You can find it in the polling tab there, and go ahead and make your choice. Again, we'll give you guys about a minute this time. I'll leave this polling question open, and just a few quick reminders for the audience before we close out the poll and take a look at the results. We are taking questions throughout the webinar today, so if you have a question at any time, you may feel free to use the question and answer tab and submit your question, and we'll try to get to as many as we can during the question and answer period. And then also another reminder that today's event is being recorded. So if you miss any or all of the event, you will have the opportunity to access it later on demand. All right, so looks like we have a healthy number of responses. So I'm going to go ahead and close this poll, Prashanto. We'll take a look at the responses and then we'll move along. Okay,
Sure.
All right, great. So the polling question was, what do you use to manage applications within Kubernetes? The majority, the largest number of folks, 31% are using Helm, and then and even 24% each are using operators and labels. 21% are using namespaces. So I hope that helps help you form your webinar presentation. And with that, I'm going to put myself back on mute and let you get right on with it.
Awesome. Thank you so much for that, Charlene. And thank you everyone for participating in the poll. We will be using the poll numbers as part of the conversation throughout the presentation. So to begin with, we have a couple of surveys here. One is from the New Stack, and then the other one is from the CNCF survey. The New Stack survey was done a few years ago. This was sometime, I believe, in 2017, 2018. But the reason why I'm presenting this right now is to talk about how Kubernetes started and what were the challenges that folks were facing as they were adopting Kubernetes. Right at the top, we see that security was paramount and is still paramount, but close to that was storage as well. So security, storage will kind of form the top layers of the challenges in terms of Kubernetes usage or adoption. Now, fast forward time, and we see, this is based on a CNCF survey from 2020. We see that many folks, almost 78% over here are using containers in production or are going to be using containers in production. And this corroborates and aligns with the exact numbers that we saw through our poll as well. I think it's 76% based on the poll that we just did, the first poll, that 76% of the respondents are going to be using stateful applications within Kubernetes. So there is alignment, there is corroboration that the market is evolving fast. The market is evolving very, very quickly from a stateless Kubernetes world to a stateful Kubernetes world. And when you have storage involved, when you have data involved, it becomes paramount again to have point-in-time recovery, as well as to have the capability of managing your data well, to do migrations, to be able to do CI/CDs, and just able to be intelligent in terms of how you manage your data. And obviously, when you think about security as well, one of the best ways of recovering from a security breach is by having a point-in-time copy. So again, when we look at all the problems that are arising within Kubernetes and the waves or the flows within the Kubernetes run, everything points to a point-in-time recovery, a migration, data protection, data management-based solution. So with that, let's talk quickly about the OpenShift container platform. OCP, as an acronym, which is used very regularly, does not need much of an introduction. If you've used Kubernetes, you have definitely heard of OpenShift as one of the leading platforms out there. So what is OpenShift? OpenShift is the platform that is for cloud-native applications development and deployment across the hybrid cloud. So what Red Hat is basically doing is it's focusing on making its users and customers capable of running their traditional applications, their cloud-native applications, their machine learning functions in the right direction, and as well, it's a cloud strategy for the future. Now, what does OpenShift exactly do? So Kubernetes as a platform lets you run your containers. It orchestrates your containers very well, and make sure that everyone gets enough resources to run and so on. However, there is a plethora of features that are required around the Kubernetes functioning itself, around the containers running, which involve automated operations. You want to have, you want to be able to manage your container ecosystem properly. You want to be multi-tenant. You want to do it securely. You want to make sure that you can expose your containers to the outside world via network traffic controls. You want to be receiving updates. You want to be able to have observability, chargeback features. And at the end, you want to have a pluggable architecture as well to make it an enterprise-grade solution. And that is what OpenShift provides you. You have your Kubernetes layer and all the ecosystem to manage it and run it in an enterprise-grade fashion is what OpenShift enables. Now, OpenShift enables you to do this across any infrastructure, whether it is a bare metal environment, whether it's a virtualized environment, or if it's a public cloud environment. So considering that you may have OpenShift in multiple different clouds or multiple different environments, and the advent or the need for running stateful applications, you are going to be running into situations where you would need to migrate or move your applications from one OpenShift cluster into another OpenShift cluster. So those needs become progressive requirement for all your customers, or as customers of OpenShift, that would become something important. Now, providing all these different features, it's no surprise that OpenShift is one of the leaders in the space. And based on one of the analyst reports from Forrester back in Q3 2020, it says that OpenShift is the most widely deployed multi-cloud container platform and boasts powerful development and unified operations across many public and on-premise platforms. And again, there are a few players out there, but OpenShift is clearly the leader with about more than 2,000 customers running this today. Next, let's talk about OpenShift container storage. So the first wave of running containers within Kubernetes involved running stateless applications, as we all have seen. And now it's becoming a lot more stateful. And to run stateful workloads, you need storage. And that is what Red Hat has provided through OpenShift Container Storage as well. There are three pillars to OCS, as the acronym for OpenShift Container Storage. The first one is agility. Agility in terms of provisioning storage and managing the storage. Scalability. Containers are massively scalable. They provide linear scalability, and that is what the OCS platform is built on as well, and enables you to provide the best performance, the best features, even at scale. And then finally, consistency. Consistency in terms of experience, whether you're running it in public cloud or private cloud environments, and also from a persona perspective. It provides that consistency layer between your developers and your IT ops, again, for managing and using the same platform. Looking at OpenShift Container Storage at a high level, it supports different types of protocols, block, file, and object. As we mentioned already, you can run it in any environment, public cloud, private cloud. It has a unified experience. And very, very importantly, it is completely used and managed through the OpenShift console itself. So you have a single pane of glass to manage your container ecosystem, as well as the storage used by the container ecosystem. Jumping into some of the key features around OpenShift Container Storage. It's highly efficient, supporting thin provisioning, inline compression, erasure coding. From a security perspective, there are a lot of encryption-based features available. Performance, we spoke about the linear scalability, but there have also been proven abilities to handle 10 billion objects as part of OCS. Manageability, we mentioned, the single pane of glass through OCP, but again, it has a powerful CLI integrated into the Kubernetes API server as well. And then it is fully compatible with multiple protocols, and it supports CSI, which is the de facto framework for communicating with storage within a Kubernetes environment. Now that we have introduced the container platform, which is OpenShift, and the container storage, which is OCS, let's talk about Trello Vault for Kubernetes, which is the data protection and the data management solution across the OCP and OCS products. So firstly, data protection is not new. Why do we need a new technology like Trello Vault for protecting cloud-native applications in general? So one of the things that we need to be aware of is that with cloud-native applications, the DNA or the architecture of the application has changed, right? We are using newer technologies to build these cloud-native applications, which our legacy solutions do not understand. When we think about legacy data protection solutions, they are highly dependent on the operating system. They are very, very siloed, focused on monolithic applications, which do not generally change footprint. And on the other side, when we think about cloud native applications, they are highly scalable, highly available, dynamic, may change their footprint in a matter of seconds and change it back again in the matter of a few more seconds. So overall, there is a change in the architecture which the legacy solutions cannot support. If you think about, if you've ever worked with Microsoft SQL Server and you've tried to do a backup, generally legacy solutions have focused on protecting the data volumes and connecting that to a new instance of the same application or a new instance of SQL Server running in another environment. And that was good enough. But when we do that, or when we look at cloud native applications, it's not just the data volumes, but also the metadata that needs to be protected in order to capture the application successfully. And that is what is missing. And that is where Trello provides value, and Trello is able to handle these cloud native applications very efficiently. Let's talk about the features that Trello Vault for Kubernetes provides. As mentioned as part of the last slide, we are fully application-centric. We protect the data volumes, the metadata objects, or the Kubernetes objects associated with the application. We are completely native to Kubernetes and OpenShift. So we are a cloud-native application ourselves, and we have built it against upstream Kubernetes. So any Kubernetes distribution should be able to run Trello Vault. And we have also packaged ourselves as an operator, which is available within Red Hat OpenShift OperatorHub as a certified solution. And on top of that, we have also ensured that the full product is managed and used or usable via kubectl. So there is no separate CLI, no separate API that a customer needs to manage and maintain to run Trello Vault. Now, from an infrastructure compatibility, we spoke about OCP, OCS being fully infrastructure compatible. Trello is also fully infrastructure compatible. No matter what the underlying storage is, as long as it's CSI compatible, which OCS is, we work out of the box with it. Along with that, we provide support for storing your backups in an NFS repository as well as an S3 repository. So you have a choice to choose either or. S3 can be any S3 compatible object storage. And again, run it in any cloud, the experience and the usability remains the same. Now, we spoke about the second poll, or when we did the second poll, we saw a pretty equal distribution between different applications. Some folks are using Helm, some folks are using operators, labels, and namespaces to manage and segregate their applications. Trello supports everything. We support backup of your Helm apps, your operator-based apps, label-based apps, namespaces, everything. We'll dive into what we exactly protect in one of the next slides. But we have an expansive suite of capabilities to support however the application is being deployed within Kubernetes. Along with that, we provide out-of-the-box integration into Prometheus, Grafana as well for a monitoring observability perspective. Now, since security is so important within Kubernetes, we've mentioned that a few times, we've made sure that we have certified this technology, going through multiple channels. First, we have gone through the Red Hat Operator certification, because of which we are available as a solution within OperatorHub. And then secondly, we have also gone through IBM Cloud Pak certification for data, multi-cloud management, and applications. Now, with these two certifications, you have the peace of mind that the technology has been constructed in a very intelligent fashion. It has no security loopholes, and the technology that you are bringing into your environment to manage the rest of your data is clean and has been validated by industry experts as well. So it provides you additional peace of mind that, hey, this new solution or this new tech that you are choosing or leveraging is secure. And then finally, what we've done is we have provided a freemium model to start using Twilio Vault. The freemium model is as follows. We have 3 different licenses. One is a free license, which is available for 30 days, unlimited use, no restrictions in terms of the number of nodes you protect, number of backups you do, or anything like that lines. The second license is also a free license, which is called a basic license. It's still free, but it's limited to up to 10 worker nodes, but for an unlimited amount of time. So the license is yours, free forever to use. And you can actually start downloading and getting jump started with Twilio Vault today itself. The licenses and the downloads are directly available from our website, so you can directly go there and request a license and start using it. And then finally, we have the Enterprise Edition license, which comes with all the bells and whistles of premium support with Customer Success Manager, ensuring that you are always successful in all your data protection management ventures using Twilio. We spoke about how we've packaged and how we are delivering the product. We have constructed ourselves as an operator, and we have an upstream operator available to deploy directly within any Kubernetes environment. And we have a OLM-based operator, which is available for OpenShift type of environments as well. So no matter wherever you're using OpenShift, Twilio follows you with your environments as part of the distribution itself. Now, let's talk about the integration that we've built with Red Hat for Twilio and OpenShift and OCS. So let's talk about OCP first. So from a OpenShift container platform perspective, one, we can easily be deployed from OperatorHub in a matter of I would say 3 to 4 clicks max. It takes about 2 to 3 minutes to deploy the operator and get it fully installed and running within a OpenShift cluster. We have also supported dynamic forms within OpenShift so that users have a form-based approach to manage and create objects and just use Twilio Vault in general. And along with that, we also have supported the YAML workflows. So if you like to do things in a YAML workflow fashion, you can use that. Or if you want to use the form-based approach, you can use that as well. So all this integration is available today. If you install Twilio Vault for Kubernetes directly from OpenShift, you will be able to play around with these features right away. Now let's talk about OpenShift Container Storage. We mentioned that OpenShift Container Storage supports CSI, and TBK requires CSI to communicate with the storage platform. There is no additional configuration, no annotations, no labeling, nothing that is required if you are using OCS for your applications. As long as the application is based on OCS storage, Twilio will automatically integrate with it, be able to talk to OCS and capture your application successfully. So overall, now if you think about this, we have Twilio embedded into the OpenShift console. You have OpenShift container storage within the OpenShift console. Now, overall, it's a single pane of glass for your container distribution, for your container storage, as well as for your data management and data protection capabilities, all within a single pane of glass. Now, let's talk about the architecture of Twilio. So the way we've done this is we've built our overall product based on custom resource definitions. Every operation, whether it is to create a backup or a restore, or to define a protection scope, or to create the repository where you store your backups, everything is a custom resource definition. So users directly interact with those custom resource definitions, fill out the template in a way, and create instances of those definitions. Then we have the control plane layer. It is at the control plane layer where we basically do the application discovery, find out all the different objects that the application is leveraging, and capture all the resource config YAMLs, and communicating with the API server and move that into the target repository. And then finally, we have the data plane layer. This is where we leverage CSI, communicate with the persistent volumes, take a snapshot of the persistent volume, and we have these data mover pods that are spun up on demand, one data mover pod for each persistent volume, which captures all the data and moves it into a centralized repository, which can be NFS or S3. So overall, pretty straightforward. The architecture is very clean, simple, and easy to follow. And the product works also in a very simplistic fashion, without really affecting or changing anything from an application footprint perspective. Now, let's talk about the custom resource definitions a little bit more and how the product works. So right at the top, there are custom resource definitions, as I mentioned, for creating targets, policies, and hooks. Targets is where the backup is stored. Policy is your automated policy to take backups or to retain backups. And then obviously you have hooks, either to extend your backup workflows or restore workflows, or to take application consistent backups. Then you have the concept of a backup plan. The backup plan is nothing but a protection scope of what you want to protect. It can be one Helm app, can be multiple Helm apps, can be multiple label apps, or multiple operator apps. It can be anything as a user that you want to define. So it could be that today your protection scope is one Helm chart talking to another label-based application, but tomorrow it becomes Helm chart talking to a label-based application, which is talking to an operator-based application. So you can just extend the scope of your backup plan tomorrow to align with the dynamic nature of your application itself. And then once you have defined that backup plan, you perform a backup operation on top of it. And obviously, there are other flags within the backup operation that you can use, which is the full backup, incremental backup, and so on. Once the backup is done, you have a backup object that is sitting in the target. Now, when you do a restore, which is again a custom resource definition, all you need to do is provide either the name of the backup or the location, the target location where you are restoring it from. And once you provide that and run that config, you get your application or whatever you had defined as part of your protection scope, you get all of those items back again. Now, what does Twilio Vault for Kubernetes exactly back up? We spoke about different capabilities. So when we do a backup of the namespace, we back up all the objects and data, persistent volumes that we find within the namespace. Anything and everything, we capture all of that. When we do backups by labels, we find firstly all the resources that the labels match. We find also any dependent resources based on the label matched resources. We capture all the pod definitions. If there are any persistent volumes associated to the pods, we capture those persistent volumes as well. When we do a Helm-based backup, we back up not only the current deployed revision, but all the previous revisions as well. The reason why we do this is because when we do a Helm backup and a restore, we maintain the application tooling consistency. What this means is your Helm app is still a Helm app after it's been restored. So your commands like Helm upgrade, Helm rollback still continue to work even after backup and restore, and we do not break that for you. Same thing on the operator side. We not only back up the operator-based resources, but we also back up the resources of the application that the operator is managing. And upon restoring, you have the ability to just exclude the operator resources if you want to do that. But again, we make sure that the application tooling consistency is maintained as you are moving these applications across, or as you are protecting them from a point-in-time recovery perspective. So Trello Vault is ready for the enterprise. What we mean by that is we provide a lot of granularity at which you can manage and massage the content of your backups and your restores. So one of the interesting features that we've built is known as restore transforms. When you capture an application, you have all these YAML files and the data volumes. The restore transforms allow you to tweak and edit those YAML files before you do a restore. So it becomes a very powerful tool when you're moving applications from one environment to another environment. We also provide the ability to exclude items, hooks, as I mentioned, to do application consistent backups. Even you need hooks for a restore operation in case you want to extend your workflow, you can do that. We also provide the capability of browsing the target where the backups are stored, so that you can easily cherry pick the item that you actually want to restore. So these capabilities are all built into the Trello Vault Management Console that I will cover in a few slides. From a database standpoint, we have been adding almost one new database that we are validating with our hooks every 10 days, and we are updating our documentation with it. So if you just look at the Trello Vault documentation, I think we have about 10 to 12 databases, include MySQL, Postgres, MariaDB, Cassandra, Mongo, time series databases like Influx, Elasticsearch is also in there. You can expect to see additional databases being added over the next few months. And this will be a continuous process. As and when we see new databases being used more popularly, we will provide a starting point to protect those databases with Trello. Now, from a security perspective, we are very proud of how we have built this product, and this is something that we like to talk about because security is the lack of security can have a lot of detrimental consequences, and we want to make sure that that does not happen for anyone out there. So firstly, we've built a product which does not require any admin access. So we have specific permissions to do specific Trello operations, which does not require any admin privilege. We leverage the default security context constraints that are provided by OpenShift. We also have documented the basic constraints that would be needed if you wanted to create separate SCCs. From a service account perspective, we have our own service accounts that are created for specific jobs. Some of the service accounts are also deployed and created at runtime, providing additional layer and padding around security. All the permissions capabilities that we use for the product, we have it openly documented in our website. It's just trello.io/Kubernetes, and you'll see all this information in there. And we've also taken the time and effort to talk about all the other enhancements and all the other pieces that we have built into the product to make it highly, highly secure and foolproof in a way. Now, Kubernetes is definitely growing at a phenomenal pace and is providing a lot of value. But at the same time, when you provide that much performance, that much speed, agility, there is something that you're giving up, and that is simplicity. Kubernetes is a great product, but it's still new. There is still a lot of it that you would need to learn and figure out. And for that reason, what we've done is we have provided our own management console to manage your Kubernetes or OpenShift clusters anywhere they are running, whether they are running in AWS, Azure, IBM Cloud, Google. As long as it's your OpenShift cluster, you can manage, as long as it's a Kubernetes cluster, you can manage it using Twilio Vault via management UI and management console. So our management console, firstly, we believe reduces the complexity of data protection, data management by a factor of 20x. The reason why we say this is because we provide application discovery. So all your applications, whether they are based on Helm operators, based on labels, independent objects, we collect all of that and we show that within our management console. We have intuitive workflows that allow you to manage your backups and your restores in real time across multiple cloud environments. We have simple click-driven workflows to perform your backup and restores as well. You use this platform as a application migration solution, between multiple cloud environments. If you have OpenShift running on-prem, OpenShift running in the cloud, you can use this securely to move all your apps from one environment to another, whether it's for performance reasons, cost reasons, whatever it may be. Yeah. And finally, I'll talk about the compatibility of the product before I hand it over to Annette, who can provide more of a proof point of how the product works and how everything is built via a demo. So from a Kubernetes distribution perspective, as long as the Kubernetes distribution is 1.17 plus, so I believe it's 4.4 for OpenShift, you can easily use it without any restrictions in prod, test, and dev. All you need from a storage perspective is a CSI compatible storage. From a target perspective, as we said, any S3 compatible storage will work. And also you have the ability and the choice of using NFS if desired. Out of the box integration into Prometheus. So we have a bunch of metrics that are sent to the Prometheus server. We also have our own dashboards. We have uploaded about 10 Twilio dashboards for Grafana directly on the Grafana project page that you can start using if you're already using Grafana. Databases, I mentioned, I think I mentioned almost all of these on the previous slide. So we are continuously adding more and more databases as time goes by. On an average, I would say it's 10 to 14 days and a new database is being added to the mix. And then finally, no matter the infrastructure, whether it's public, private, edge, core, anywhere you are running OpenShift or Kubernetes, Twilio can function out of the box over there. So with that, I'm going to hand it over to Annette to put this all into practical terms by showing us a demo of how Twilio works with OpenShift.
Thank you, Prashanto. I'm going to share my screen. So am I sharing?
I don't see it yet, Annette.
Okay.
Something's coming up. Okay, I see it now.
Yep, it's there now. Yep.
Sorry. Okay. All right. So let's get started here. My name again is Annette Cluid. I work for Red Hat in the Data Services Business Unit and have been working with Prashanto and others on the team to integrate our OpenShift container storage solution via CSI with Twilio Vault for backup and restore. So I'm showing here what I would call cluster 1. And on cluster 1, the OpenShift cluster, I have Twilio Vault, the latest update for Twilio Vault, the operator, installed. And I also have OpenShift container storage. On my second cluster, I have similar Twilio Vault and OpenShift container storage. So the other thing, these are OpenShift 4.6 clusters. And also it isn't shown here, but we're going to be using an S3 bucket on AWS as our off-platform target storage. So the application that I want to back up is a WordPress application. I've installed it on cluster 1. I've added at least one article here. And if I go to cluster 1, go down to projects, and search for WordPress, I'm going to see that this application is made up of pods, PVC services, all kinds of OpenShift metadata, as well as persistent data. And the PVCs were created using an OpenShift storage class here for what we call Rados block or block. So this is block storage. And this particular application takes 2 persistent volumes to back up both for WordPress and for the MySQL application. So the other thing I have going here is I have the Trilio Vault Management Console that Prashanto mentioned. I have one of those open on each one of the clusters. So what I'm going to do to show moving the WordPress from one cluster to another is I'm going to first do a backup of the WordPress application. And it's quite easy to do. I choose the namespace I want to back up. So this is a namespace backup. I then create my backup plan, and we'll just call it WordPress Backup Plan. I choose the target. Again, the target's already been created on AWS. And I could fill out other things. I could add hooks if it was a database or an application that I could coalesce, add policy and so on. But in this case, just to make it easy, I'm going to go ahead and save that. And then I'm going to name this particular backup. Once I do that, I need to choose my plan here. And the little check mark means I've chosen the WordPress backup plan, save, and then the backup's starting. So while it's moving along there, let's just look at the terminal. So on the terminal here, I have, if we look here, I'm in the WordPress project. And what we're going to see here is that we have a new pod that was just created about 19 seconds ago called Meta Mover. So this is going to move and save the OpenShift metadata. So let's just put a watch on that. And also let's look for volume snapshots. So volume snapshots are a custom resource within OpenShift that are basically what's created when the data is snapshot. So you see these just popped in here. And we also see that the persistent data is being, we have 2 new PVs here to mount in order to get the data into the S3 target. And if we go back now to our console, we can get some more information from the console. And we can go to view details. It'll show us what things have been completed. So this would be the OpenShift metadata now has been copied off platform into the S3 target. This shows that there was a snapshot done and completed. And now what's happening is it's mounting the snapshots and going to, again, copy that data into the S3 target off platform. So in a short time here, this will be completed. And we can see that these pods, they're temporary pods. The metadata pod is completed. The data mover pods are still continuing. And at the end of this, the new volume snapshots will actually be gone. So actually, let me make that a little bit easier to see. So if we just do a watch on OC get pods, comma, volume snapshot, we should see that they are gone. So like I said, in a short time here, as soon as this data mover action is done, these volume snapshots will be deleted. And if we go back to the console now, go ahead and get out of here. We're almost done. We're 80%. There we are. We're done. And again, just to show, the volume snapshots are gone. So what that means from the point of view of just being able to look at the data is that the data, the snapshot is created and stored into the OpenShift container storage, self-storage, but it is only there for a short time. It's mounted, data copied off, and then it's deleted. So now we have our backup, and we could do OC get backup, called it Wordpress. And it'll give us the status of it. So it's available and it was successful. So on the bottom here, I have this is my login to the second cluster. And what I want to do now is I want to restore that WordPress into the second cluster. So the first thing I'm going to do is I'm going to create a new project called WordPress. Okay. So I have that now, and I'm going to go back to my console, go to the second Trilio. So again, this is my second cluster here, and I'm going to go and find that backup plan. So the way I do that is I select my target. I go ahead and launch the browser after I sign in again. Okay, so we'll go back to that again, choose my target, launch browser, and here is the backup plan. If I click that, it shows me the backups I have available. And we just created this backup of the WordPress application with that one article. So now what I'm going to do is I'm going to restore it to the second cluster. I'm going to give it a name. I have to choose a namespace. You notice that I created that empty namespace right before I started this. And I'm going to only select this one. If something already exists, don't create it again. Hit next. And then I am going to add a transform. And the kind I'm going to do is that it's going to be based on the route. So when I get the WordPress on my second cluster, the route will be different based on the second cluster having a different domain name. So I'll click on that, call it T1, and I'm going to change, it's called spec/host, and I'm just going to go up here. This is the primary one, and I'm going to change it slightly to be the secondary one. Put it here, have to put quotes around it. And I'm going to change, this says PRI, I'm going to change this to SEC. Just validate that here on the second cluster. Yeah, SEC, good. Okay, so then I'm going to apply this, save. And if I want to check my transformation or transform here, I can see that it's going to replace it with that value. Hit save, restore started. Now I can watch the restore in a couple different ways. Let's go back to here. So right now we're in the WordPress project. And so I can do a watch on OC get pods, PVC. So there's no volume snapshots here, right? The volume snapshots were used on the other cluster via the OpenShift container storage to create the snapshot so the data could be moved off platform. But here we're using the snapshot data to restore the application. So let's go back to our console. We can view how the application is progressing by going to the restore here, and then we can take a look at it here. So that is not a good thing. All right, this is what happens during live demos. I'm wondering if it's that transformation. Let me just go ahead and I'm going to go ahead and just try it without the transformation. So we'll go back here, go to target. I may have bungled that transformation, launch browser. Hit here, boom, restore. We'll call it WordPress Restore 2. And before I do that, just to make sure, I'm going to delete this. Delete project WordPress. Okay. And I'll create it again. Okay. We'll just start the watch since I'm already here. Okay, so let's go back to our console. And I'm going to choose WordPress again that I just deleted and recreated. Go here. Next. And we'll just go ahead and save it. We won't add that this time. So again, we can take a look at it from going here. Click here. And click here. So WordPress Restore 2 is doing a bit better here. We can click on it. We can see it's going along here. So let's go back to our terminal. And I'll get rid of it now that we know the restore is working. Just do a watch on here. So similar to the way that it works with when you're trying to do the backup, there's pods. These data mover pods are created. They're temporary pods that are going to take the persistent data and the OpenShift metadata. You see there's a meta mover there that's already completed. But the data mover pods are going to move the persistent data into the PVCs. And then once that's done, it'll recreate the application pods. So we can also monitor that here. And it says validation. So let's just click that again. So we finished validation. We're on to data restore here. Again, it looks like we finished the WordPress persistent volume. Now we're doing the MySQL. Finish that. Now we're on to the metadata, which would be the OpenShift data. And soon we should be done here. So we have just finished the moving of the data. We see that the WordPress on MySQL pod have already started running here. So let's go back. So what we want to do here, and this is where if the transformation had worked, so the issue with this is that it is the route for the other cluster. So what I'm going to do is I'm just going to do this. I'm going to delete that route here. I'm going to expose this service again. And again, if whatever happened on the first restore, so you see now that the route, because this is on the second cluster, has SEC. I can go ahead now and copy that route, put it into a browser, and voila, I am now have WordPress working with the same article that I had on the first cluster, which was here. I now have this article and WordPress completely installed on the second cluster. So I think that's it. Prasanto, I'll hand it off back to you.
Awesome. Thank you, Annette.
Okay.
I am just trying to share my screen again over here. Okay, so thank you for that, Annette. That was a wonderful demo. While we had that issue with the first restore, I just did a quick. Oops, actually, I'm sharing my wrong screen. I just did a quick background check, and it was a syntactical error on the transform. So it was just the extra HTTP because of which it did not work, and we caught it during the
validation. Okay.
Okay, but that was a wonderful demo, and what we actually achieved was moving an application from cluster 1 to cluster 2. Everything was up and running superbly in the second cluster as well. So with that, what I'll conclude by talking about the joint solution value. We've definitely seen a wonderful demo of the overall product in action with OpenShift and OCS. And what this overall provides joint customers is the ability for backup and recovery, point-in-time backups and recovery, ability to do disaster recovery in case you lose your entire cluster. You can inject Twilio into your CI/CD pipelines if you want to do testing within public cloud environments for scale and performance reasons. And obviously for migrations as well. Now, the cherry on top is obviously you have a single pane of management via OCP if you want to be functioning within the OCP interface itself. You have click-driven workflows via the Twilio management console. The entire stack end-to-end is certified by IBM and Red Hat, and it's fully multi-tenant and self-serviceable. So each of those operations, what you saw around creating policies, backup plans, backups, restores, you can delegate it to your end developers and your end users, and have a fully multi-tenant architecture available to use. So with that, Annette and I both thank you for your time. Thank you for patiently listening and watching the demo. If you're interested in learning more about Twilio Vault, you can go to our website and download the product, watch your demo, do live environments, however you want to get started with it. With that, I conclude the presentation and can take any questions that we have in the chat.
I just responded, Prasanto, to a question about does Twilio Vault pause instances during backup? And so I did, anyway, I did say that it can pause via hooks, can pause the application.
Exactly. So so we have hooks which can basically acquire the application, and that's how we have qualified and certified multiple other databases, which we have it on our documentation website itself.
Yeah, and it was asked also, can I restore snapshots to a completely different OpenStack cloud? I said, Kubernetes and OpenShift, absolutely, that's what I showed. But OpenStack is more of an infrastructure platform, not so much a container platform. So but OpenStack or OpenShift and Kubernetes, absolutely.
Definitely. And I see another question from George Lopez, it says, this will not work for OCP3.x? Not yet. We will be. So we do require CSI to function and communicate with the storage. So that's what you need. But in the future months, as part of our roadmap, we do have plans to support non-CSI volumes as well. And that's when we will be supporting any kind of underlying storage, CSI or non-CSI as well.
And the question, does this work between different OpenShift or Kubernetes on different infrastructures? Absolutely. OpenShift is supported on Azure, AWS, all kinds of infrastructures. So it's really infrastructure agnostic, what I showed you.
Exactly.
Thank you so much for both of your expertise, Annette and Prashanto. My name is Jade. I'm on the back end at DevOps.com. We're experiencing a little bit of technical difficulties with Charlene's audio. We're going to close up the presentation, but really quick, I just want to remind the audience that today's event was recorded, and you'll be receiving a link to the recording a few hours after we wrap up today. Additionally, we had mentioned at the beginning of the presentation that there's 3 gift card winners, and those 3 gift card winners are Steve W., Wendy R., and Danielle D. Congratulations. Thank you so much for spending an hour of your time with us, Annette, Prashanto, and our attendees. Your time is valuable, and we wish you a great rest of your day.
Okay, thank you.
Thank you, Jay. Thank you, everyone.